thank you so much for the introduction and thanks for having me here. I was very happy to receive the invitation, very happy to be here. As said, my name is Heli Kymäläinen. I know my last name is a bit of a nightmare for all people not speaking Finnish, so you can just call me Heli, it's very fine. I got quite free hands with the topic, so today I will focus more on the human factor side and this machine development we have going on here in the Nordics. And I hope I will be able to give you some insights. Let's see if I can change the slide. Yes, so I come from the University of Eastern Finland. We are quite north and quite east, located in Joensuu campus. This is a very nice place to do forestry, do forest research. We have all degrees of forest education in the region, vocational University of Applied Science, and then our School of Forest Sciences here in the university. We have the European Forest Institute headquarters here in Joensuu, just across the street. There is a big office of Natural Resource Institute of Finland. We have a lot of companies, private companies here. John Deere Forest Machine Factory is in this town. Ponsse Factory is just few hours away. There is Kesla, Argonaut, lot of different companies. Forestry sector is still quite big sector in Finland. I just checked that last year around 17% of all export euros came from forest sector. We have a lot of private forest ownership. Around 60% of all the forests are privately owned, and mostly they are like family-owned forests. And mostly the privately owned forests are in the southern part of Finland, where the forest growth is much more better than the northern side. So the government forests are mostly in the northern side of the country, and that means that the economical side of the timber trade is the family forest owners are doing a lot of economic with this timber selling actions. We harvest annually around 60 to 7 million cubic meters over bark, depends on the year. And now to the actual topic of today. So during the last 15-20 years, more or less all the forest harvesting operations have been fully mechanized, so more or less 100% mechanization level, and it's all cut to length harvesting. It's not all clear cutting, so around 40% of all the harvesting operations are done with thinnings. So both clear cuttings and thinnings are very important to us. About a little anecdote or information. So we have a high mechanization rate in forest operations, but also regarding, for example, measuring methods of these commercial roundwood fellings. So almost 85% of all the timber that we are harvesting, we are also measuring with the harvesting machine. And this is like also one anecdote or one principle, one side of the machine operator's work. So here in the Nordic, the operating a forest machine is quite demanding. The job description is quite wide because they are all also responsible of the measuring of the timber that they are harvesting. So they are calibrating the machine, measuring devices at least every other day. They are checking that the devices are in order. And not just the calibration devices, they have to be, because the machine operators in the thinnings, they are selecting which trees they are taking and which trees are left in the forest. They have to be aware of the different kind of forest management principles. They have to know the raw material quality, because you cannot just, you have to provide quality raw material for the sawmill industry, for pulp mills. The machine operators, they have to be able to maintain the machine, to operate the machine very effectively. It's a high investment for the machine contractor. So we are talking about more or less nowadays, let's say 600,000 euros if you are going to buy a new harvester machine. So they have to be productive in their work. They cannot just sit there and think what to do. They really actually have to produce a lot of production. And of course they have to be able to maintain the machine and make all the, at least the smaller repairments of the machine. So this all demands quite a big skill set, and it takes many years of practicing and experience to become a real professional with good productivity. And of course, the work is often located in rural areas, long distances from the towns. It's super independent. That independency is also a good side, because it's a big motivation factor to the machine operators that they are able to work independently and like in peace, in their own peace, and with like close to nature. That is also like a positive thing for the operators. They also, some of them like that it's very motivating to them to be able to operate this kind of modern big machinery as well. So, however, the work outcome is strongly influenced by the operators' capabilities, resources, skills. And nowadays, when we are looking at the bigger picture, there is also growing pressure from the society that can we use our forest? How can we use our forest? Is it okay to harvest? Should we leave it growing? And even if these decisions, the forest owners are making the decisions to cut or not to cut, but because of the machine operator is implementing the work, they are often getting some feedback about the forest use, and they are taking it quite personally because they also want to make a good work, and they are receiving very controversial feedback of it. Well, some other general challenges we have in a global scale also. We have a growing demand of wood material overall, even in the most cautious scenarios. We have a global need for more sensitive harvesting operations, but also mechanized forest operations can provide much more safer, effective, and more accessible way of doing harvesting operations than just manual work. So it gives a lot of advantages. Also with the CTL method, it's possible to do rather sensitive harvesting. You can do thinnings, you can do continuous cover, forestry, maybe even some selective cuttings. Of course, you have to have the machine road when you are going in the forest with the machine, but it's more safer way than just manual cutting. Global level, we also have lack of professional, skillful machine operators. In some countries, we have the education for the profession. In some countries, not. The companies are educating the operators themselves. In Finland, we have this situation that a lot of young people who have had the education for this profession, they soon realize that it's quite demanding and they are changing their careers to something more straightforward, not so complex work environment. And of course, we have the aging, at least in Europe, the population is aging and we need more doers in all the occupations. So from these challenges, I've been doing some studies that how could we support the machine operators? How could we introduce more people in the field? How can we make the careers even longer? How can we develop the professionality of the workers? Some key findings from my studies, we can assess, we can estimate this kind of workability index. And with machine operators, this workability index decreases with age, so the resources to do the work. And it's very, very much in line with other studies from other occupations. Even with this modern machinery, we still have vibration, noise, this kind of physical strain that is quite demanding, straining from the machine operators, at least in the long haul when you are doing the work for decades. And one other thing, like this more mental side of the work, if you are operating a machine, it's very hard to get promotions in your career. You can either operate the machine poorly or super well, but it's hard to get promoted to another work. So usually when we are talking about these professional workers, like white collar workers, when you have cumulative professional skills, you usually be promoted to other work tasks, or your work tasks are widening, your projects are widening. But when you are operating a forest machine, you are operating more or less the forest machine, no matter how good you are in it. So this is one thing that can also decrease the workability index, the resources, the motivation to do the work. I noticed that there was connection between the productivity, the workability index, and also in the recovery of the operators. So the more stable they were sleeping and the better they had their recovery, the better was also the productivity that they were doing. And the overall workability index was also higher. With these modern machines, CTL machines, it's not about the physical work anymore. It's a lot of to do with cognitive ergonomics, like this mental strain. They have to do a lot of decisions. They have to observe the surroundings all the time and the machine all the time. So it's heavily on the cognitive ergonomic side, the work strain. And also it depends about the work organization, how well we have organized the work, because the work is very independent. They are doing it alone in the machine, so it has to be organized very carefully so that the work would be efficient and they wouldn't have to wonder in the work site what to do or what not to do. Of course, we are interested about the future, what might happen in the future. We have some projects been going on here at our university. There have been all these new sensors that are coming. They provide new possibilities. For example, now the biggest machine manufacturers, they have introduced these precise positioning, precise GPS in the machines are now available. This boom tip control is getting more and more improved. And during the last 6 months, at least John Deere, Ponsse, I think also Komatsu they have introduced a lot of these kind of half automated, how would you say, assisting systems that ease and supports the operator and ease the work. In this picture, we had this Ilmostar project that ended last year. We put a lot of different kind of sensors to the harvester machine. I believe there was like 6 LiDAR sensors and 4 these kind of precise GPS sensors and cameras, 360 cameras, GoPros, and so on. And we were measuring how much we could obtain the information from the surroundings and what could be provided for the operator. Of course, with the sensors, it's still a big challenge, the forest environment. It's very rough for the sensors. So they are still not in that point that they are robust enough to handle the forest environment very well. So that's a big challenge still to overcome. And of course, with the sensors, we are getting more and more precise data. We are going towards the precise forestry. This is a picture from our synthetic project that is still running. And actually, we are having field tests in a couple of weeks here in Joensuu. And also this project, we are trying to create real-time assistance for the operator to support the decision-making with real-time bugging, with this LiDAR-based real-time bugging. And we are still studying the options for tree quality measurement with the LiDAR and the biodiversity, like to have understanding of the biodiversity of the machine surroundings with the LiDAR. And of course, when we have more and more information and it's more and more precise, there is a big risk that the information will overflow to the operator because there is only so much that the operator can handle in one minute or one moment of time. So at the moment, we are writing this paper about the ergonomics of the machine operator. We were interviewing 50 operators here in Finland about these different kind of assisting systems. What are they using at the moment? What would they like to use? How would they like to have the information presented for them? And for example, in our study, the operators were more positive with this kind of holographic screen or screen information with the screen. They were not so enthusiastic or not so happy with like smart goggles or these VR glasses on them. So they don't want to actually wear anything. They want to have the information some other how. Here is, I'm sorry, some of the writing here is in Finnish, but we also did this importance performance analysis in this study to map a little bit what are the most important for the operators and what are not so important. So the operators think that already there is quite nice performance. So this upper right corner about the key habitats, the bugging information, the strip road, so the machine road sharing with the forwarder is working quite nicely. Boom tip control is quite okay. Revise camera functions are rather okay. These are supporting their work. They are already quite nicely working, but of course there is still some room of improvement. And with this right down corner, there was this possible overkill, so things that they don't use and they don't appreciate. So that was a lot about these sounds and alerts of the machines. So no more sounds in the machines, please. And yeah, the feedback is something that has been coming through in all the studies, whether are we studying it or not. So it's also very important to have the communications and feedback in order when you are working alone. So you need to have quantitative and qualitative feedback of your work. There is no other way you can improve your work if you don't have any feedback. That is absolutely something we have to concentrate in the future. But yeah, from the ergonomical point of view, whatever the future development steps are, or the mechanization level is in the operations or the automation level, I think it always comes down to this bigger picture, how we are organizing the work and how we are organizing the data flows, communication, chart descriptions, that everybody knows what they are doing and what they should be doing and who to contact if something occurs and so on. In first glance, the machine operator is working alone in a machine in the forest, but actually they are connecting with different kind of networks every day to get the best outcome from the whole supply chain. Thank you. I think I've used my time already. Here are some studies I've been involved with, and I've gathered this presentation. Kiitos paljon. Thanks a lot.